Hi, we're the Martian Maniacs. My name is Christopher Cisneros. I'm an aerospace engineering major at El Camino College.
Hi, my name is Jonathan Kim. I'm electrical engineering at El Camino College as well. Christopher and I were in person for the HAcK event.
We were in charge of building the circuit, wiring everything, and making sure everything was put well together.
This was our first iteration of the LCD, which we just powered from the Arduino connected to the laptop.
At this point, the LCD was still connected to my laptop for power, and the potentiometer allowed us to control the brightness of the display so it could be seen.
We were having issues with the LCD when we actually plugged it into the merged circuit, and we fixed it by plugging two more 9-volt batteries into ground and the 5-volt rail, or the power rail of the 9 volts. And as you can see, we got it working on the right.
Our original code had the LCD display showing error when a movement key wasn't pressed. And to give our rover more character, more personality, we had it blink, we gave it a motion, and that's as you see in the video on the right.
That was our second iteration of the face. And this was our third, where we were supposed to have 8 different faces. This is one of them, where it was moving from right to left when we made the robot move left and right. However, we weren't actually able to get that to work. So we changed it to just have 3 faces going in the loop, where we have a happy face, a chinky face, and a sad face.
This is our first iteration of our arms. What it was 2 servos connected to the laptop and getting the information from the ESP32. The servos move in unison as our arms eventually would.
This was our first iteration of the robot arm, where we were able to connect it to a Bluetooth serial monitor from our phone. However, we weren't able to use this Bluetooth connection to our phone because it would give us an unfair advantage over the iPhone users, to the teams who only had iPhone users.
When we actually connected our arms to the rover, it missed the box, missed its backpack. It was supposed to make it in. So what we had to do was shorten the arm by about 1/2 inch and also make the angle more downward. That way it would be a shorter travel.
This is just Chris assembling the robot. He did a lot of the assembling. He's very good with things like that because he likes Legos a lot. He's good at assembling things.
This is everything put together. I would control the robot using WASD on my keyboard, and on my laptop, it would show which direction the rover was actually moving.
So on the left here, this is a diagram of the of what we use to base our merged circuit off of. However, this right here where it says BAT is what caused three of our ESPs to break. And we fixed this by plugging it into USB instead of BAT and powering the ESP through the Arduino.
This is the final circuit. On the right, we have what the guts of our rover look like. Every red wire is connected to power. Every black wire is grounded, black or brown. And every yellow is a PWM connected wire that sends information. On the left, you could see it a little more clearly, but the batteries were not connected at that point.
So our field test went terribly because we weren't able to connect our robot to Bluetooth when we got there. We believe this is because we were changing out the batteries right before the field test, and we might have got a loose wire because we went back to the makerspace after Chris was tinkering with it, making sure the wires are fully plugged in, and we got the robot to work again. But the field test didn't go well.
What we learned from this, that engineering is not always perfect the first time. What we'd like to do next time is have a more secure power source, make sure our wires are fully plugged in before we headed to the test area. And the best thing would have been to not change the batteries right before, but it needed to be done because there was no more power.
Hello, my name is Daisuke Asai, and I'm a student at El Camino College studying computer science. I worked on CAD modeling for the robot arm, LCD screen design for the robot's face, and UI connection. I will be going through the design process of each parts that I worked on, as well as the challenges that I've personally faced. So for the CAD model design for the arms, we first acknowledged that this would be one of the hardest parts of the process. So our team agreed that we mostly use laser cutting so that we could design and test a variety of arms. I designed 9 total versions of arms, including the ones shown here. Although I designed a shovel-shaped arm and scoop, we figured that it is best to implement a hook design for simpler assembly and having less chance of the pickup parts going out of bounds. Our final designs was set to these 2 arms. We created 2 separate arms because we realized that one arm wouldn't be able to pick up the 2 differently shaped objects. For our first arm, we had 2 iterations. I simply rotated the side of the hook by 90 degrees to accommodate for the shape of the pickup box. The second arm had 3 iterations where we added a 0.83 inch long and 0.10 inch wide hook to the initial design. And then I added a rectangular box that removed the gutter that was in the hooking part so that the pickup box didn't get stuck there. For the LCD screen, I first thought of designing the bare minimum of 3 faces. But while I was iterating through the faces, I realized that I could make the face move or have it animated. I wanted to add a distinct personality to our robot that was unique to our team, so I decided to create animated faces for each actions the robot took. Here's 2 of them. So one improvement I made was to simplify the code. Since the code was getting extremely long, I used simple for loop to simplify some codes, which also saved me time when coding. But when I uploaded the codes for the screen to Arduino, the face didn't correctly display. We had to simplify the code and only include 3 static faces to fix the problem. We think that the problem was we didn't have enough battery power in order to power all the components that our robots had. Here are the 3 faces that we included in our final product. I was able to make the UART connection to work with my first test, especially because the code required was mostly 1-line code. Here's the code and the actual product that we were able to create. Here's a visual note I wrote for my team to better understand UART. Once the USP32 computer receives a command from the computer itself, it sends another command to the Arduino Uno via UART, in which the Arduino tells specific physical components to take a designated action. However, after uploading the merged code to our robot, we experienced several issues which made our robots not functioning. Continuing from the LCD problem we faced, we are not sure if it was UART that was causing the problem. My team had a great chemistry even online because Chris was able to set up an iPad at Makerspace where we had continuous communication. We knew communication was going to be a big challenge, and I think we adjusted to our circumstances very well. I was one of the few people that did not have the physical parts in my hands, so every testing of the robot had to be done through another person. Because of that, some process got delayed, and it ultimately led to the results of our team not having enough time to fully test our assembled product. If I were to do the hack again, I would dedicate a larger portion of time to testing regardless of the progress we made. Next, I would like to pass it on to Min Hao.
Hi everyone, my name is Min Hao Ren. I transferred from Pasadena City College, and my major is computer science. Since I work remotely, I mainly worked on writing the codes for the movement of the wheels and the dents. I also helped troubleshoot by assembling the car at home. On the first day, I tested out the codes for 2 motors to automatically move forward, backward, and stop in a loop using Arduino Uno. It was successful. However, when I tried adding the Bluetooth connection using the ESP32, it did not work. So on the second day, I got rid of the Arduino Uno and connected ESP32 directly to the motor controller. The motors were successfully controlled using the processing commands. The next step was to make 4 wheels to work. So I connected 2 wheels to the left side of the motor controller and 2 on the right. To make the car turn left or right, I coded it so that when making a left turn, the right wheels are moving, but left wheels are not. And the same idea for the right turn. Next, using the diagram shown on the right, I powered up everything with battery instead of just my laptop. And the car is moving remotely. Then I drew out diagrams and sent over my codes for my teammates to try them on. For the dancing code, I made different functions for each movement. For example, forward and backward functions. I wanted the robot to dance to the song Baby Shark, which has a half time of 58 beats per minute. Therefore, I used delay 4138 after each movement. which means there will be one distinct movement for 8 beats, or approximately 4 seconds.
I want to say thank you to all the mentors for taking the time to teach us during our training and help us during any little hiccups we may have had during the actual HAcK competition. Thank you to Wes for inviting us. And I really enjoyed working with these guys, working with Jonathan, Daisuke, working with Minhao. It was a great time. Martian Maniacs was an amazing team.
Great experience. Thank you so much.
Here's a little clip of our rover finally working at the end. Thank you, everybody.